Hello, welcome to this video mini lesson introduction to normal distributions. You see here a histogram representing a normal distribution. A normal curve is made from a normal distribution by marking the midpoint at each bar in the histogram and then connecting those midpoints in a smooth line to create a normal curve. So a normal distribution is used to create a normal curve. Now, most distributions may approximate a normal distribution, but will not be a perfect normal distribution. However, a perfect normal distribution is known as a standard normal distribution, which is also known as a z-distribution. We're going to be talking about z-distributions and z-scores a lot in our upcoming work together. Now, one of the things that you can do is think about normal distributions as useful for parametric statistics. Parametric statistics are statistics that involve measures based on parameters. A normal curve gives you certain parameters that you can use, certain sort of boundaries or rules, so to speak, that you can use to make certain calculations. For example, in a z-distribution, the mean is always considered the point of zero. And essentially that's because the mean represents the point at which half the scores are above the mean and half the scores are below the mean. So it kind of makes sense to have that point be represented as zero. And in a z-distribution, one standard deviation is represented as 1 unit. Within a normal curve, almost all points, in fact 99% of points, fall between plus and minus 3 standard deviations from the mean. So 99% of all points fall within minus 3 and plus 3 standard deviation points. Now that said, a normal curve is what is known as asymptotic, which means that this line, although approaching the zero, will never actually reach it because hypothetically there could be an outlier score that is outside of the normal curve. Also, the inflection point is the point at -1 and +1 standard deviations. That represents the point at which the curve becomes steeper and no longer represents the most substantial percentage of score points. Now, I do want to point out that these numbers here represent the number of or the percent of scores, or the percent of the total distribution that falls within these points. And these numbers here are actually rounded to the nearest 0.5%. That's key to keep in mind. And also, I want to point out that this might be a little bit hard to wrap our heads around, but use of the z-distribution will really help us in some calculations and making some assumptions and drawing some interpretations on data. But you have to think about it much as you might think about, say, a thermometer. Now, temperature is something that sort of occurs in nature, so to speak, and also what occurs naturally is the finding that mercury rises or gains in volume as temperature increases. But what humans have done in creating the thermometer is they've associated certain points with certain increments of rising of mercury, and those are all human-made or manufactured points, so to speak. So humans decided that it would be 32 degrees Fahrenheit or 100 degrees Celsius would represent the point at which water freezes, and that 212 degrees Fahrenheit and 100 degrees Celsius would represent the point at which water boils. Similarly, if you think of shoe size, that's another manufactured human thing. You know, most shoe sizes fall within certain bounds, and shoe sizes, or most feet lengths, I should say, will fall within certain bounds, and shoe sizes represent the most common of those feet lengths, and they're translated into different shoe sizes as you see here. But again, these are human manufactured representations of the length of the human foot. And those manufactured sort of sets of measurements are made to make our lives easier as humans, and that's what we have with the z-distribution. And in the next video mini tutorial, we're going to introduce ways that you can use the z-distribution to calculate certain points in certain areas on the z-distribution or the normal distribution. As always, please let me know if you have questions. Thank you.